Hello again. This tutorial is going to be on ANOVA. ANOVA stands for Analysis of Variance. It is used if you want to compare three or more means. It breaks variation into two components, okay? It breaks variation between groups, and I'll explain that later, and then it breaks it in, it looks at the variation from within groups as well. There's underlying math for analysis of variance. We're not going to go into this at all. We're going to be using Minitab, and what's important for you folks to do is to be able to interpret the output of the Minitab data. So let's go over an example. A manufacturer of paper grocery bags wants to increase the tensile strength of their bags. They believe tensile strength is a function of the percent hardwood concentration in the pulp. They believe the range to test is 5% to 20%. And there'll be 5% increments within. So we're going to test 5%, 10%, 5%, 10%, 15%, and 20%. And there'll be 6 replicates for each percent hardwood concentration, and those 6 replicates will have their tensile strength recorded. Okay. First, we have to set up our hypothesis. All right. Our hypothesis here is set up that essentially that as we increase our percent hardwood concentration from 5%, 10, 15 to 20, there will be no change in the output, which is the tensile strength. Okay? Our alternate hypothesis is that there's going to be a change for at least one of them. All right? The significance we want to test at is 0.05. Okay? And remember, if the calculated p-value is less than alpha, we reject the null hypothesis. Okay. This is a table of our data that we're going to input into Minitab. All right. We have the 4 concentrations here, and we have the resultant tensile observations in PSI. So we place the data in Minitab, and we select ANOVA and one-way ANOVA, as you can see right here. And why do we call it a one-way ANOVA? The reason why we call it a one-way ANOVA is because we are only changing one factor or independent variable, okay, to see if there's a difference in our dependent variable or response variable, okay? In this case, we're going to have 4 levels or treatments within our independent variable. Okay. In Minitab, they call it a response and a factor. So in this case, the response is tensile strength, the factor is hardwood concentration. And remember that our alpha of 0.05 is our significance level, so our confidence level is therefore 95. We place that right there. Also, we need to select on graphs here, and this dialog window opens up, and select box plots. Always very good to look at the box plots of the data. And then this is what the output comes out. So in this session window here, the ANOVA table pops up, as well as this box plot graph. Now let's look at this information, okay? First thing we should do is look at our graph, all right? We can see as we increase our percent hardwood, there was an increase from 5 to 20, but there doesn't seem to be a great as increase right there, okay? If you recall, our alpha is 0.05. We look at our p-value. Our p-value is right there. Is p greater than or less than alpha. P is obviously less than alpha. So we will reject the null hypothesis. Okay. But let's go more in depth here, okay? So let's take the ANOVA table. Let's quickly go over what these numbers mean. This first guy here is called the between group sum of squares, all right? This right here, this looks at the differences between the averages for each level, okay? 5%, 10%, 20%, 15%, and 20%, all right? This next one right here is the within group sum of squares. So it's looking at the variance within each level, okay? So it's, let's say, 5%. All right, we have 6 values within there. So we're going to look at the 6 raw score values, that each individual tensile strength to the average of those 6 data points, okay? We total those up for the sum of squares. And this is important in calculating our R-squared value, all right? This next column here has our mean square treatments, all right? And these are calculated by dividing our summation of squares by their degrees of freedom, okay? And degrees of freedom here, we have 4 levels, 5, 10, 15, and 20. That's where we're getting 3 right there, okay? Our next column here is our F, and this is the statistic that we're going to use to determine whether or not we accept, or we retain or reject the null hypothesis, okay? And that's the F ratio, and it's a ratio of the mean squares. It's calculated simply by dividing the mean square treatment by the mean square error, okay? And the F, in essence, is very similar to how we're doing the T test. So this is an F test, and it's the F is an unbiased estimator of the variance. So instead of looking up the F in the back of the book for an alpha of 0.05 and for these 2 degrees of freedom, we're going to let Minitab calculate the p-value. P-value is essentially 0 here, and that's telling us what the probability that all these averages for these levels, the likelihood that these averages are equivalent, all of them are, okay, next to 0, all right? All right, that data says that yes, there is a difference between the means, but it doesn't tell you which means are different. So there are 2 things we want to look at. Let's go back to this box plot. Okay, these guys look fairly similar, but these guys don't. Okay, let's look over here. Right here is the individual confidence intervals for the mean. Right, put this little line right here. So it's a very simple graphic that shows you the range. Okay, for level of 5, 10, 15, and 20. All right, 10 and 15% don't look different. 5 and 20 are. Let's also look at this R-squared value. This R-squared value tells us how much error have we captured in the difference of the response variable, which is tensile strength. All right? So we are capturing 74% of that error right here, and that is calculated by taking our hardwood concentration right here. This sum of squares divided by the total. Okay, so it means we're doing a very good job. This is, very good R-squared value. Okay, so the one that they select was actually this percentage makes sense. But also, if you're looking at let's say we're looking at it from a cost standpoint. Let's say we're trying to get the highest percentage in there, say the highest tensile strength for the lowest cost. Then we would start looking at these things right here. Maybe we do a t-test and fine-tune these 2 levels right here. All right, so that's ANOVA for you.